Welcome to your second class on Introduction to Lamb Navigation. In this class, we'll talk about the navigation technique called dead reckoning. Now, dead reckoning is the technique of traveling at a set distance along a set azimuth. So, for example, if someone told you to move 300 meters at 25 degrees, you'd be dead reckoning because you're just looking at your direction and distance. Now, dead reckoning has a lot of advantages. First of all, it's simple, it's easy to teach and to learn. It's easy for short movements, getting to an exact point or to a specific location. It's good in times of limited visibility when you can't look around and see terrain features to judge your movement off of. And it's also good when there's no visible landmarks, like in a desert or thick vegetation where you can't see very far or you can't see anything of note within your area that you can kind of base your navigation off of. Some disadvantages for dead reckoning is that it's time consuming, as we'll see. There's some math involved sometimes. It's harder for longer movements because if you're off slightly on dead reckoning, it's not self-correcting. And it's difficult to adjust for unplanned obstacles that come in your path. You have to leave your azimuth and then return to it. So I'm going to take you through dead reckoning from start to finish, and there'll be a little bit of some review here. But hopefully it's helpful. So say you want to get from point A to point B. Point A is this road intersection. Point B is this point here that's at the end of this draw. So first thing you do is you pull your compass out. You would put the straight edge of your compass along from point A to point B. You'd rotate your bezel. And you determine that it's 30 degrees from true north from that intersection to that point. Now we know that we got to adjust, so that you know that's 30 degrees here. We go down to our declination diagram. We determine that since the magnetic north is over here to the east of true north, we have to subtract, and we subtract this 16.5 degrees and determine over here that the angle we need to travel off on our compass is 13.5 degrees. A trick here is if it's east, you subtract. East is least. And if magnetic north is west of true north, you add. So west is best, least is east is the trick there. All right, so we've done that. Now we need to determine distance. That's pretty simple. As long as this scale on this compass matches the scale on your map. So if this is a 1 to 25,000 map, we can simply use the edge of the map to judge, or edge of the protractor here on the compass to judge distance. So we see here these are in kilometers. This is 0.5 kilometers, 1 kilometer. So each of these tick marks is 0.1 kilometers or 100 meters. So it's 1, 2, 300 meters, about 350 meters at 13.5 degrees. So we know the distance and direction we need to travel. Now, when you pick your compass up off your map, in order to travel in that direction, all you need to do is you already have your direction set here. You just need to line this red arrow for north up with this arrow here. So you simply turn it, and then we know we move off into this direction. Now, when you're dead reckoning, it's important the concept of shooting an azimuth. That's because it's really difficult, unless you're staring down at your compass the whole time you're moving, to keep these lines lined up, and you'll end up drifting to the left or right at some point in time. Now, in order to prevent that, we shoot an azimuth. What that basically means is we take our compass, we line it up with a point in the distance, and then we move towards that point. Now, this is an example of a lensatic compass, and this simply shows you here that the compass was designed in a way that you can easily shoot an azimuth and look down and see exactly the degrees that you need to travel just by pointing in the direction of an object. And so there's two different techniques that we borrow from the military for shooting an azimuth. One is the palm-to-cheek method, or hand-to-cheek method, and that's simply like shooting a rifle or a gun. You're looking down the sights here. We line that up with the target out here, which is the point we want to move to. The second one is the center hold method. Basically, you line this up with your chest, and you look straight down this lining up the line with an object in the distance you want to move to. Here's some civilian compasses. The ones with the mirrors on them are actually easy to shoot. They're classic hand-to-cheek method. And then for the more common non-mirrored compasses here, orienteering compass, what we'll have to do is the center hold method. Now you'll have to practice this on your own, but the basic idea is we pick a point that's readily identifiable. The further out in the distance, the better. But for example, here, an easily identifiable thing in the distance here is this tree, and we line it up at 13.5. We know if we move exactly to that tree, stand at that tree, and shoot another, find another piece of terrain in the distance that we can readily identify. We can just keep moving in a straight line from point to point all the way to where we need to go at 13.5 degrees. Now the problems arise when we hit an obstacle and we can't go straight. Like this time, we're moving and we come across this lake. Now what do we do? There's two different methods. The first method is the box method. Now the box method is kind of complicated. I'm going to move through this fast. You can find a lot of this, and I don't really recommend you use this that often, but it's helpful when you can't identify something on the opposite side of the lake to move to. So say you're moving at 13.5 degrees for 50 meters. To do the box method, we simply turn 90 degrees, which is 13.5 plus 90. We move at 103.5 degrees for however long it takes us to get to the other side of the obstacle. And then we turn 90 degrees to the left, which is put us back on a regular azimuth for however long it takes us to get across to the other side of the obstacle. Then we turn 90 degrees to the left again, and here we go. Here's where the math is. 13.5 minus 90 gives us a negative number, and we simply subtract that from 360 degrees in a circle to determine that we need to turn left. Puts it at 283.5 degrees. We travel that. Make sure that this distance you travel is exactly the same distance that you traveled here. So these two cancel each other out, and then we know that we simply turn another 90 degrees to get back on our original azimuth of 13.5 degrees, and we have 200 meters left because we moved 50 meters here to the lake, 100 meters this side of the lake, and then 200 meters to our target if we're moving 13.5 degrees for 350 meters. Now, the simpler method, and the method I kind of recommend if you can see the other side of the obstacle, is to do the shooting across method. And even if you can't see the other side of the obstacle, if you could find something on the map, an identifiable terrain feature that you can find on the ground, this is probably a better method to use. And that's because it's just simpler for you to compute, especially when you're tired. So same scenario here, you're moving 13.5 degrees for 50 meters, you get to this lake, you look across the lake, and you see off in the distance here, there's this little cabin. So you pull out your compass, you say, that's 13.5 degrees, that's right on azimuth. So I'm just going to make my way around the lake, doing this lazy walk here, move in and around objects, so we get to that point, and then we just continue back on azimuth. Now the problem here is we lose complete track of our pace count. When the box method, we knew exactly how far we had traveled. In this method, we don't know how far we traveled, so we'll have to rely on the map and reset our pace count and start it up again. So this has been a long class on dead reckoning. But I think we covered a lot of ground here, and the next class we'll talk about terrain association.